India is one of the few nations to have its own satellite systems. This is the reason that the country has become self-reliant in areas like weather forecasting, national security, disaster management, agricultural development, urban development, land resource assessment, as well as monitoring. All these tasks are made easy and accurate today by geostationary and geosynchronous satellite imaging. The Earth is continuously observed by the telescope systems mounted on the satellites, and the images are captured. The main part of the telescope system is the mirror. Optical signals are collected by the primary mirror in the telescope, and it is focused and reflected on the secondary mirror. These light signals are then converted into electronic signals and sent to the ground station, where these signals are converted into images. Naturally, the quality of an image has a lot to do with the quality of the mirrors used in the telescopes. Therefore, scientists never cease to develop better mirrors for space applications. The International Advanced Research Center for Powder Metallurgy and New Materials, Hyderabad, engaged in the development of new materials for the last 2.5 decades, has made unprecedented efforts in this direction as well. This autonomous R&D center of the Department of Science and Technology, Government of India, is working on silicon carbide-based mirrors for space applications. Due to its higher specific stiffness and thermal characteristics, this mirror is more efficient than the currently used Zeroda, beryllium and other mirrors. Powder formulated with organic binders and sintering additives is used as a raw material for the fabrication of these mirrors. First, raw silicon carbide powder is compacted into simple shapes by uni-axial pressing. The compacted parts are then subjected to cold isostatic pressing and low-temperature heat treatment. Green machinable substrates are then subjected to light weighting and profile generation in a CNC machine. The finished parts are then sintered at high temperatures under an inert atmosphere. These substrates can meet the structural and thermal requirements of a mirror. ARCI has developed its own technology for producing lightweight silicon carbide substrates of various shapes and sizes. To use these substrates as reflecting surfaces, a dense coating of silicon carbide is applied through chemical vapor deposition. This removes the non-uniform microstructure of these components as well as the residual pores. Reflecting surface is then generated through surface grinding, diamond paste polishing, and iron beam polishing. In this way, a surface roughness of less than 1 nanometer is achieved, which is quite remarkable. Silicon carbide-based tertiary mirror coupled with silicon carbide cold finger will be used in the visible line emission coronagraph, the main payload of India's solar probe mission. With its expertise and experience, this premier R&D center is providing state-of-the-art indigenous solutions for several applications. These achievements of ARCI are strengthening the Make in India campaign.